Okay, so in this video, I would like to share some of the strategies, techniques, and frameworks that I use when building agentic solutions on Microsoft 365, Azure AI Foundry, and the Microsoft Power Platform. This is going to be use cases that you have a business requirement that is not a good fit for Microsoft Copilot, and you really need to build this from, I'm going to say from scratch, but piece together and have more control over the AI capabilities, and also to leverage your existing skill set with the Power Platform, leveraging Power Apps for the UI, Power Automate for the middle tier, as well as the workflow and the batch processing, and then using AI Foundry for the closed and private models with OpenAI, even some of the Grok that's running in Azure, the Minstrel that's running in Azure, and some of the Hugging Face or even DeepSync, if you're going to run that in the Azure landing zone where you have control over all the information coming in and outside of the model. So what I want to do, let me just switch over to the whiteboard, and I'm going to be toggling between the whiteboard and the presentation just so that we stay in sync. So here's the requirement. So the requirement is that you have your users. They're going to interact with a set of contracts. And what we're going to do, they're going to batch upload these contracts. You're dealing with 800,000 contracts. It's a large amount. The reason why it's a large amount is what we want to prove is when you're faced with a task that would take a lot of human capital, this is where the light bulb should be going off to say, can we leverage AI, or how can we leverage AI to solve this problem, right? So we got 800,000 contracts loaded into a SharePoint library, and a couple of things that they need to capture from these contracts. They need to capture the executive summary. They need to capture the party's signature. They need to capture the expiration date, the renewal terms, if it's auto renew, that's a flag, risk assessment, risk level. Now, the difference between the risk assessment and the risk level is that you're going to give it a level 1 through 5, and then why the AI gave it a 3, that assessment would describe the justification behind it. Because of the sheer number of contracts, we actually want to run this on a batch. So there's going to be a batch job that scans through each one of these contracts and then run it through the LLM and extract out this data. And then once it extracts that data out, it's going to populate each one of these data points in the respective SharePoint column on that document library. Okay, so, and obviously because these are contracts, oh, that's the other thing. Let's put in the contract type. Because these contracts range from many different types. They can be lease agreements, master service agreements with a vendor. It could be a non-disclosure agreement with a client or vendor or contractor. So they're going to fall into many different contract types. So this is going to be all the metadata that's pulled off and then dropped here. Okay. When you look at this, if we use the contract AI agent as an example, the first thing you want to do is gather requirements. It seems obvious and no-brainer, and this is exactly what you should be doing, and everyone should be doing this, but you would be absolutely surprised of how many people skip this step and it comes back and bite them. We break this down into 3 main categories. We're gathering information, documenting what we gathered, and then we go into a design or a prototype to highlight what we cut out of it. So basically the way that we work this is that you will get a series of workshops. This could be 1 to X, the number of workshops you need. We try to define those up front, but you'll see out of certain workshops, we get other workshops that are needed, a more deep dive that is needed. So in that series of workshops, what we do, we will, before that one, again, we try to highlight what we're going to cover. So everyone, business owners, sponsors, project managers, business analysts knows what topics we're going to cover. Ideally, the Scrum Master or the product manager will schedule these ahead of time. In these workshops, we invite the SME, the people who are working the process, the department or areas that are impacted. This could be one or many. Usually a sponsor or someone who's driving this initiative like to just sit in on the first one just to get a sense of it. Let me slide this over. One of the things I don't highlight here is the kickoff. Right. So let's say there's a project kickoff and the sponsor, like all the responsible parties, the leaders who's responsible for this initiative would join this kickoff. All the SMEs, all the contractors, everyone who's involved, business, the product manager, everyone joins us. This is a pretty hefty meeting, probably 20, 30, 40 people, but everyone's on the same page of what's the mission and the ultimate goal. From there, we have the series of workshops. So this would be workshop 1, workshop 2, 3, 4, so on and so forth. And each one of these workshops are driven by a particular topic. And ideally, what we do is get a rough swag of the workshops that are needed. And in this kickoff, we highlight that calendar. We highlight, here's the workshop, here's the topic, and this is the date. We try to keep these workshops between 30 to 60 minutes. In these workshops, there is more listening than talking from our perspective because we're there to learn about your business. We're there to learn about the process. We're there to learn about your pain point and why this team is engaged. So once we kind of get through this and we cover the topic, all of these workshops are recorded. That's very critical. This is an AI initiative, and one of those patterns and practices we tend to incorporate using AI not only to build applications, but also in the project management process, right? So each one of these would be recorded. The Scrum Master or the product manager would do. This could be a mix of the business analyst or whatever, but someone who's responsible for organizing this meeting, making sure the right people are attend to this meeting. If critical people cannot make the meeting, reschedule, they're responsible for the meeting notes. So from here, everything will be recorded. The meeting notes are generated, and usually that's stored in some type of centralized repository. So it could be OneNote that's tied to a Microsoft team that all have all of the assets related to the project, and you have a folder that says meeting notes. So anyone at any time can go there and get up to speed on what these meeting notes were about. Now, if you're super advanced and you're implementing or leveraging Microsoft Copilot, an ideal scenario with that, when you have that meetings folder that would just capture all of these meeting notes from all these different workshops, even stand-up meetings that you have, that person, if you're really fancy, you will create a Copilot agent and then just point it to that folder. So at any given time, you're just asking natural questions about, okay, give me the summary of workshop 1. Who attended? Maybe if you capture attendance and stuff like that. What are the key takeaways? What are the decision points? What are the open questions? So you're having that natural conversation against that folder that has the transcript of all the meeting notes captured from the workshop. The next thing we do is that from these workshops, another output or deliverable would be the requirements document. Again, during the conversation, a lot of details are captured in that conversation. We're ultra engaged doing these workshop meetings because we don't really have to take notes because the recording is capturing that from us. Now, I may take like mental note or capturing certain topics that I want to circle back to in that meeting. That's something I do personally, but I'm not trying to capture all the details because the recording helps me do that. The business analyst would do, they would collect all of these meetings, recordings, and that feeds into their business requirements document. And they create an outline, they create that business requirement document. We detail out the assumptions that were made. We detail out any open questions that are made. We detail out any technical deep dives that the tech team or the solution architect need to capture. So then you have the business requirement. Also, from the business requirements document, we create a workflow process diagram. In the scenario of this contract agent, we would have something like, okay, we have this document library, and then we have this repeatable job that runs. When it processes a contract, it's going to set a timer or a schedule. Because this is a batch and because we have so many, this was going to use the batch AI API process. So we detail all of these out. Maybe we use the O1 model or the O3 model to create that executive summary. Maybe we use a 4.1 model to extract out the metadata because you need deep reasoning, wherever your case may be. So, we capture the different models that we have. We capture the process. How often does this batch job run? Is this batch job restrained to only running a certain time a day? There's 800,000 that it needs to chew through. Will you run multiple jobs simultaneously and chunk the data up so the jobs are not stepping on the top of each other? Who needs to review these once they are processed? Is there a service level agreement, meaning that if the human is looking at them, maybe the human needs to get this done within a certain number of days. Maybe they're spot checking. Maybe we're building an AI monitoring service to where you have the AI monitoring the AI. So all of those details we try to capture in this design diagram. We love the illustration piece of it because anyone can look at it from a bird's eye view, or even if you want to zoom in, you understand where all the pieces of the process go and who's involved with the process. And then from there, we also create a POC or a interface just to kind of capture what that proof of concept would look like. Here's an example of an AI contract agent interface. And this will ideally be built in Power Apps, or you can create this as a React front-end app that calls services, or you can even create a React front-end app that called Power Automate as a service. So that way you take advantage of the connector framework to interact with SharePoint libraries and things along those lines. The benefit of this POC or interface when you start prototyping is to get everybody on the same page of how that UI is going to be developed. This is a critical step because everything we've been discussing has been theory, concept, pie in the sky, someone's vision, one person imagine it being this way, the other room is imagining it and, looking at it in a different way. This kind of consolidate and brings everyone on the same page, and more importantly, help identify what the gaps are. Help identify, we need more metrics than this, or these are not really that important. Another KPI or metric to capture is XYZ. This is what, the library or a glimpse of the contracts will look at. These are the key titles or information that we want to capture or showcase here. Here's an ability to reason or ask questions for that selected contract. Here's an option or feature to ask questions across all the contracts, even with a chat history built in. This is where we really start to elaborate and detail out what this is supposed to look like, as well as a way to close this window. It's like, hey, maybe we should have X so we can close an open window. That may be important. Maybe adding new contracts, what that experience look like when you add a contract. Where do you want to drop that? Is there like a drop box that those contracts get added? Does someone need to be notified? So on and so forth. So you flush all of these items out, all the different views, selecting the contract, the detail of this dialogue, so on and so forth. And as of May of 2025, if you're not using vibe coding to iterate through this quickly, you're missing the mark. Unfortunately, interaction with UI, UX designers, again, throw the darts at me if you like. I think those days are numbered, if not already coming to an end, because the back and forth in the interaction and really just because this is what happens, right? This is why today's age is super important. As a product owner or business owner, you know what you want, you know what features you have, you understand the business process. How it comes together on the screen, you usually leverage or weigh heavily on a UI, user interface, or user experience expert to help you with that process. The AI is just going to take your concept. You're not going to describe, this is the color scheme I need. I want a grid table, and then the title, the headers need to be grayed out. The details need to be white. Give the title of the contract or the contract ID a bolder treatment than anything else. Design and pending should be yellow active. Like, you're not getting into that level of detail. The AI just takes your concept and say, oh, here's a bunch of documents. They have statuses. Look what it's doing with the risk. Maybe there's a threshold, like anything in low risk under 30 is green. Anything over between 50 and X number is yellow. Anything over a certain number is red. It came up with these different concepts. Right or wrong, at least you have a canvas or baseline to start throwing darts at and fine tune it. And you're going to get from concept to UI in a matter of hours. This is not a 2-week, 3-week, 4-week engagement with UI, UX designers, none of that, right? So the way we're iterating, the way we're executing, it's exponentially faster when you leverage AI in this way. This is not AI in the app. This is AI in your process. Using AI as an assistant to help get work done. We're just stacking the AI because we're using AI as an assistant and an agent to get work done, to build an AI application that's an agent that run through and validate and analyze contracts. Make sense? So, okay, so this is going to be our step where we do our prototype, proof of concept. This is our step where we do our diagram and workflow process. And this is our step where we do documentation and requirements document information, right? And all of that stem from these workshops that we have, and we kind of drive it. And not to say that these activities have to wait until all the workshops are completed. They actually start after the end of workshop 1, maybe 2. But by the time we get here, we really have a foundation, and we're just adding on and adding on. And then by the time we get through all the workshops, everyone has a really good understanding of what we're doing. So all of this is before we build, right? And I know it feels waterfallish, right? Even though we try to do this in an agile way. From my experience, and I'll love to hear your feedback in the comments, how many organizations are true agile? True agile in the sense of, here's the idea, build it within these 1 or 2 sprints, and after the sprint, deploy it to production. That deploy to production usually is a waterfall type scenario. Sizing the project, like how many companies have a blank check that says, build this thing in agile, keep going until you get it done, and then we'll just react to the cost, right? They want to know, like, no, you need to do some level of planning, some level of architect design, some level of effort, so we can have a breadbox size of how much this is going to cost. So that piece right there is waterfall. The agile piece is actually in the middle. Maybe the workshops. In this sprint, we're going to get through these 2 workshops, do a deliverable. Next sprint, the final 2 workshops and the deliverable. This sprint, we're going to start building. What we don't do, even though it feels like it's a hybrid of waterfall, agile, that waterfall towards the end is really to push it to prod. In that build process, we are somewhat using sprints and deliverables and sizing up and pulling things from the backlog, keep the business engaged along the way. And that's critical, right? And that's just like through demos or whatever the case may be. What does that look like? This is under the umbrella of Microsoft 365, Azure AI, and the Power Platform. I love the Power Platform to create agents because I get to leverage the skill and the tips and tricks I've already mastered with the Power Platform. I'm rolling that into infusing those with AI or repositioning those skill sets in that framework we already have in the organization, re-architecting them to work like agents where you can do a web or interaction of multiple agents, creating that agentic architecture. So when it comes to build, these pieces remain the same. This is a really good transfer of skill, even if you're leveraging these tooling for agentic architecture, because you have a Power App that's going to be your UI. You're going to have Power Automate, which you can do a headless agent, or maybe you have, an agent as a service, or maybe it's more of a microservice where it's an agent triggered based on an event, or it could just be the batch agent that's executed through a batch process. The repository is the same concept, it's the same theory that we have with any Power Platform solution or any business solution for that matter. Where is this data going to be stored? What is the right storage repository for what we're trying to do? Now, a lot of people struggle with this, but really it boils down to three main categories. Right? One, are you going to use SharePoint? That's usually a bucket within itself. Or do you need to use Dataverse? Or is it dictated based on the data that you're interacting with that you need to use one other repository? When I say repository, I'm saying like SQL or Oracle or Cosmo DB or DB2 or whatever. It could be a REST API, but usually there's a repository that's part of your solution where you need to store it. The biggest question I see a lot of people get tripped up with is, do I do SharePoint or do I do Dataverse? Some people are making the Dataverse decision when it should be SharePoint. Some people are making the SharePoint decision when it absolutely should be Dataverse. What is the big difference? Here's my litmus test. Security is at over 5,000 items. Oh, it's 40,000 items. SharePoint can't support that. That's going to be Dataverse. No, it's not the number of records. SharePoint can support up to 30 million records, 30 million documents in a single document library. The 5,000 threshold is a real thing. You just need to fine tune or optimize that list or library for a large list. AI search, indexing columns, identifying your views, indexing anything that you're sorting by, filtering by. Be careful on how you create the schema, because you can't do indexes against multi-line text or some other rich column types. All of that you should be aware of from an architect perspective. The number of records does not decide this, and I see that mistake. The huge deciding factor is security. I have this many records. I have these records in this repository that we need to store. Let's just talk about the contracts. Like the dollar amount, I only want certain people to see that, or you have to be in a particular role to see that. The auto renewal, I got certain columns that only certain users, and when I say certain users, it's like the role in the application should see it. That is a very clear distinction that needs to be Dataverse, because you cannot secure columns within SharePoint. Now, role level security, you have to look at a little bit deeper, because off the shelf, you can do role level security if the scenario is they can only see the items that they created. So, for example, if you had a team of people that are different departments working on various contracts, you got one department focused on leases, another department focused on MSA. As a lawyer or contractor, you can upload contracts, but when it comes to viewing the contracts, you can only view the ones that you created. In that scenario, you can use SharePoint. Another scenario is that everyone can see everything, and certain people only want to see certain things at a given time, and they want to be able to filter on views. And there's so many variations on how to do that. You can't capture everything up front, so you have to give them the flexibility to interact and create those views. I really like SharePoint, especially if I don't have the column level security and my row level security is supported, because what I'm going to do is allow those users to interact with that SharePoint library directly and give them the flexibility of that rich view capability, the fact that you can create views, you can modify columns, you can sort, filter, you can export, like all that capability you get for free, right? So instead of having to recreate and build over that, SharePoint becomes the winner for that, right? Dataverse is really a security play. I'm not really driven because I have a model-driven Power App, so it has to be Dataverse. I usually don't go that route with these solutions unless the requirements dictate that. Leveraging your skills and your ability to use what you already have done with Power Apps, what you've already mastered, and all those tricks you have up your sleeve when dealing with Power Automate. And then, as we discussed briefly, your decision-making framework to determine the right repository or database for your solution. Let's dive deep into this one. If you're not doing this already, you absolutely should gravitate using solutions within Power Automate and really solutions within the Power Platform. One of the key features that we take full advantage of in Power Automate is the ability for one flow to call a child flow or to call an existing flow. And what we do with these existing flows, this becomes our reusable service layer. And for AI solutions, this becomes critical because the way we interact with the AI is something that we try to create patterns around, and we create reusability. If you've seen any of my previous videos around AI solutions, architecture, design, tips and tricks, you would notice that I'm very strong about reusable services in this way, especially when interacting with the AI. There's so much change and movement in this space. The models you're using today is going to quickly be an '07 model in 18 months or 24 months, right? So you want to be able to take advantage of the latest models because they get smarter and cheaper. It is to your best interest and your company's best interest, with the bottom line, to get your usage smarter, your app smarter, as well as the cost of usage lower. So you absolutely want to keep a pulse on that. There's a lot of repeatable things that we had at the services level, and one of them is the prompt catalog. Our prompt catalog is nothing more than a SharePoint list. For several reasons, we built a framework that will go to that prompt catalog and grab the right prompt for that agent at the right time. You can stack these. One call may call 5 different agents, and each one of those agents have their different prompts or instructions on how to behave, what information to ingest, what they need to do with that information, and how they need to output that information. Some of that may be HTML, it may be XML, it may be JSON, it may be JSON only, it may be a Boolean value, it may be an integer or a number. So having those different prompts all in one spot allows us to fine tune based on the results and data we have and get those spots. So this is going to be a prompt catalog. It's using in the SharePoint list in the site collection that's not related to any application. So I would imagine that like a common site collection. I think we call ours the AI app site collection. Anything that used by all the site collections, like the logging, the prompt catalog, ... will be in that site that's independent of the site collection related to that solution. And the Power App is really just that. From our Power App, we usually do either a SharePoint list form Power App because they're interacting with the view. We're not creating data tables or galleries to represent that data. We're leveraging the view to represent the collection of the data with all the security. We just want to give them that natural feel in that SharePoint list where if they select an item, it pops up with our custom Power App form to represent that data. We also love to leverage this to only show data that we want the users to edit. And we know that these views come with edit and grid mode. So we disable that and we drive what they can see and what they can edit using a combination of the view and the custom Power App form for that. The other design pattern that we have for Power Apps is that we will create a rich canvas app that allows them to select an item and then modify that item here in the middle. Also, this could be a data grid where you select a particular item and it pops open a dialog box. And we all know there's no dialogue component within Power App. So we have patterns and practice on how to do this in a repeatable way, scalable way across all Power Apps in many different scenarios. And we love this, right? So we can save it, we can extract it, we can do all kind of fun stuff with that. So that's going to be our design. So based on what you see here in this prototype, you can quickly carve this out that says, oh, okay, this is going to be a responsive Power App that works great on mobile and desktop. This is going to be my header section container. This is going to be my container for my left sidebar. This is going to be my container for my grid, my modern data table. This is the dialogue that we're going to create. We have a rectangle in the back to give that illusion of a blackout. So that way the focus stays here and the user cannot click on something that's behind the screen, keep them focused on the dialogue, force them to use these action buttons or this action icon to close or view a document, whatever the case may be. So if you're familiar with Power Apps, you can easily identify what your components are going to be, how you're going to lay this out, so on and so forth. Okay, so that's going to be, we kind of talked about this one here, like building the AI solution. The one thing that we do a deep dive, especially from a solution architect perspective, is what type of AI components do we need in the back end? I mean, when I say AI components, obviously we're going to have Azure AI Foundry. And Azure AI Foundry, we know that that's carved out into two main spots. I'm going to try to do this proportion right. Two main spots. What you have here is Azure OpenAI. And what this is just a model catalog for everything OpenAI. This is most of the time the preferred set of models to leverage because of Microsoft's relationship with OpenAI. What you see in the green is the model catalog. And they have different libraries that we're all familiar with, especially as users of ChatGPT. So it's very clear that, you have deep reasoning models, you have deep research models, you have standard models that's a balance of reasoning and speed. You have many models that focus on speed and reasoning. And then you have all your other models to where visual AI, where, you upload an image and instead of extracting OCR, it's actually looking at that image. You can upload a video with different models, right? With visual AI, it will watch the video. So you can say, what scene was the girl with the orange jacket? When did she walk in the room? Like, give me that time marker when the girl with the orange jacket walked into the room. You can't describe that in any transcript because it's not something that was said. It was something that is observed. So the visual AI, all those models come into play. And then you got real-time models that are really meant for conversational AI. Conversational AI, you can't use like a 4.5 where it's doing deep research because that pause and that wait time is not going to be a great experience. So you got AI that streams back the response. You also have, here's one that I really love, and we use this a lot in a chat history type AI solution. Before this was launched, what ends up happening is that you have almost like a chat GPT, right? So you got the sidebar, you got history of the chat, then you got the chat box and the input here, and then you have a button here. Basically what's happening is they ask a question, they hit select, hit enter, and then the AI does this thing, it responds, right? And then your question is captured here, just like a text message. So it's ask and response, ask and response. With that, every time they ask, you call the API. And again, we're used to this, right? We're used to this user experience when I'm showing you it's table stake. But as a developer, to pull this off, when I select this chat icon for this document, I need to chat against that document. I'm asking the AI questions about the context of that particular selected document. To pull that off, you need a chat history, because any question that I ask needs to consider what was already asked and responded to in that new question. So to do that, when you create that message array, of course, you're going to have the system prompt of what it needs to do, but then you're going to have the user text and then the assistant response, the user text assistant response, the user text assistant response. So every time you hit this button, you have to send that information out. And every time you hit that send, you have to pay for all these tokens. And the more history you get, the more tokens you pay for subsequent messages. So the response API, this guy here, what it allows you to do is that you still ask your question, right? So you have your system prompt and your user question and your AI response. When you send that API request, when it responds with the answer, it's going to give you a response ID. Now, on subsequent calls, reference this response ID with the new user question. What that's going to do is when it gets to the server side or the model, it's going to use that ID and reflect on what was said, what was responded to, what was said, what was responded to. So now you kind of get this history. Now you have to look into the details of this responses API, because there's a certain time period of when responses will be available. As a developer, we save this chat history somewhere. Usually there's a chat history list that we create. The reason we save this, because the same way if you're used to like bearer tokens, where you have to do a bunch of overhead, get a token, that token is only good for a certain time frame. So you have to build processes in place that says, okay, here's the token. I'm trying to use this token, and you get a response back that the token is expired, not valid. So you have to go through your authentication again and get a fresh token. And you do that behind the scenes to where you're not bugging the user for their credentials. You just know how to refresh that token, right? The same is true here. This ID is only going to be good for a certain time frame. The last I read, I want to say it's like 30 days. So it's sizable. It's like 30 days or something like that of how long that response ID is going to be good. Does it refresh after every time that you use it? I don't know. But you need to bake into your process that if you go to use a response ID and if it responds back that it's invalid, you need this chat history to send a boatload of everything that was said up until that point. That response will have a new ID. Then you do something, you store it, and then you continue on with your process. That's why I gravitate towards OpenAI, because of the different models. We already have use cases and patterns and practice on how to leverage those, and that responses ID that's going to save us a ton of money. With the token, our responses are actually going to be a little bit faster, because my networking call of all this chat history, especially when the chat history gets longer, is that much faster because I'm not passing a lot of data for every question, right? Here, we help identify and come up with the framework. Do we have to use a RAG pattern? In this scenario, with the contract agent, you do, because with this agent, contract agent assist, each one of these are vectorized data. That's the only way you're able to ask questions against that particular document. Then you got the general chatbot, AI chatbot or AI agent that allow you to ask questions across all the documents. So in that scenario, what you would have to do is create, before I used to use Azure AI search for this, and it would point to all my documents in a blob storage, and then it would chunk up automatically. It would vectorize automatically. It would know what embedding API or model to use to create the vectors. And I would just leverage that same vector to vectorize the questions. And it had the re-ranker already built in. You had to set some special settings for semantic search and all these other good stuff. And if you want to get granular, you had to go in and define different skill sets and leverage different skills to extract the data during the ingesting and indexing period. There was a lot of work to get that, and we had mixed results. I since then moved to Cosmo DB. I'm super familiar and comfortable with databases in general. either NoSQL or SQL databases, and how to write the queries to fine tune and get very granular on how I wanted to answer the questions or create the model for the AI to answer different questions. If you're familiar with Cosmo, you know that Cosmo is NoSQL and it stores everything like a JSON, right? A JSON document. And then you have these properties on the JSON document, and these are like what would be columns in your SQL table, and these properties and values are automatically indexed. These properties can be very rich. You can have a property that has an object as a value, or you can have a property that has an array of objects as a value, so on and so forth. So these could be very rich, structured JSON files. Another thing, and you have to be careful with this because you can get yourself in trouble, this schema does not need to be the same for every document in the same container in the Cosmo DB. You can mix and match these different JSON documents within the same container, giving you a lot of flexibility of what you need. And granted, that flexibility comes with a cost, because now you need to understand all these different schemas and account for when a property you're trying to go after may or may not exist, run into null value situations and all the other stuff when you expect a value. I moved to this because what we can do now is create, like, for example, and this may not be right because I'm a freestyle this design. So when you look at those contracts, the first thing you have to do is that I'm not going to store the blob of the file in this document library, in this Cosmo library. This needs to be all the text that represent that contract. I have an AI that's going to extract the metadata, and I will conform to standard names for all of that metadata and map the columns in the document library. The next thing I'm going to do is that for a particular contract, these contracts can be one to many pages, right? Real world scenario, you can have a contract that have 500 pages. So when it comes to vectorizing a contract of that size, you have to be intentional on how you chunk and what vectors you create for that contract. In that scenario, I also almost have a one to many scenario for a given contract. So imagine if this is the contract and it has 500 pages tied to it, right? What I'm going to do, I'm going to write a process that, and I just assume it's PDF. I'm going to build a collection of pages to represent that one PDF where each item in the collection is a page. So I got my pages broken out. Now, in this vector container, or maybe this is the database, let's say they're a database. So this one's going to be my contracts, and this is going to be my contract vectors. And with the contract vectors, for any contract, you can have multiple vectors because I'm breaking up the vector sizes chunks by pages. So that's why I break that PDF into multiple pages. And then here, I'm going to have the content, the text that represent the page, and then I'm going to have the vector that represent the page. And then that way, when I do a vector search, it's going to give me all the matching vectors based on that query, return it, and then it's going to do a join, right? You're going to have to do this with link query because, there's no join statement in Cosmo, but you're going to do like that join type link query that take all of these vectors that match that question and the metadata that represent the contract as a whole, and then feed that back to the AI in your Cosmo. Because I need that level of granularity, right? This is why I love Cosmo. 2, I think this came out in early 2025, if my memory serves me correctly. The vector ability within Cosmo was a thing that made it a contender for AI type searches, being that repository to allow you to search on data, rich data, structured data in that way. Secondly, it has full text search capability. So that allows us to do both keyword and semantic search against that context in addition to vector search, giving us a rich result set when it comes to the RAG pattern. And we just seen this thing grow like gangbusters. And one of the use cases we have here is that you need that type of flexibility. Here's the other thing. This AI search had to be flexible enough to search on one contract or all the contracts. When it comes to this design, because we're using Cosmo, if you come in and you do a question and you pass a contract ID, guess what I'm going to do? In that query, I'm going to limit that to only that specific contract ID. So it's going to give me this record, and the question it asks is only going to be against the vectors related to that record, of that parent record, right? Now, the scenario where you want to do a search and you don't know which contract has the answer, I'm not going to use that contract ID filter. I'm going to just do, hey, let me go against the vector and let me do my query against all of my contracts and then come up with the answer that way. If the scenario is, oh, maybe you want to limit it to some of this metadata, right? So say, for example, I want to search on documents, but only for Acumen Corp, right? Or only for Strategic Partners LLC. I need to search all the contracts for this particular vendor or for this particular party. Or I need to search all the contracts that are under a certain dollar amount. I need to search all the contracts that are over a certain dollar amount. This model gives you all that flexibility. Filter on a certain domain and still do your vector type question and answer in the AI natural language way. So it's a rich capability. So what's next? Testing. Just like you do with, this is carryover for what you're used to today. When you're testing out these AI agents, you absolutely want to unit test. This is usually done by the developers and the engineering team. They look at real business use cases captured in that requirements document that we talked about, or they can go through the notes. If you're fancy, maybe you have a Copilot against all the meeting notes of the different workshops, the different stand-ups, You may say, hey, I remember somebody said something about X. You're asking that question against the Copilot, and it's going to grab you that data based on the meeting notes. The deployment process is the same. This is why I like the Power Platform, because pushing the solution from dev to QA to production, you create in those Power Platform environments to represent those different environments becomes a very natural, easy thing. We love to keep our testers in the QA environment, and we keep our engineers and developers in the dev environment. That'll allow them to test while we're bug fixing. If we do Agile, these set of requirements are done. Go ahead and test those out, give us feedback while we work on the other requirements. So you get that separation in the environment, allow you to do that dual process. And then QA testing. With QA testing, what we love to do is have our testers go out there and imagine this is our contract agent. They go ahead and test. We give them an issues list. If they find a bug, they're going to write it to that issues list. We may have a meeting set up where we go through these issues lists. We rate it as high, medium, or low, with the understanding that everything high must be done before go live. Anything medium, is if we got the time, we'll address those. The low ones, 9 times out of 10, we're not going to address them. So let's rank. Usually they're nice to have, or usually it'll be nice if we did this, but it's not a showstopper. That ranking is critical. Because what you want to avoid is to be in the scenario where everything reported must get done. You would never get the prod. It would just slow you down from getting the prod. That's why that ranking is critical, to make sure that our MVP is addressed and we're putting something in the hands of the users sooner than later. This is all about the culture at the organization. Because if the culture is get as much done as we can now, because it's going to be a while before we circle back. So this becomes very painful because they realize there's no V2. V2 is probably 24 months away. Certain people just need everything possible to make this happen. And if you have a timeline and a budget to accommodate that, it is what it is. That level of negotiating tends to happen. We give them an issues list, we triage the issues list, make sure it has the right priority, and then we go from there. Sometimes we will size these up. So in addition to the issue, the description, and then the priority of the issue, you may have a level of effort, right? So critical items that have low level of effort are usually the first to go, right? And then like, okay, this is a medium effort or this is a high effort. High critical item, that takes some time to get to. And again, it's all the negotiating piece there. So then defect resolution, we talked to that, rinse and repeat. You just keep going through that until you're comfortable. Usually you want to tackle all the highs and get a sense of timeline too, right? This is where Agile and Waterfall really start to conflict, because the people who are writing the check, who are sponsoring, who are driving this initiative from the top, usually want to have some type of date. Like, okay, when would this be in production so we can communicate out that this is coming, and the legal team or whoever need to update their process. Communication is absolutely critical, especially when you start planning those go live. So that communication window, you want to have broad. Usually the people who are impacted by this new system, this new AI agent, they're not informed the day before. If that happens, someone missed a step somewhere. The team that's impacted the most should be communicated to very early in the process. And they should be able to see demos and be part of the testing and, right? You want to minimize the surprises as much as possible. Then what you do, you come up with your go live steps. Can we deploy this during business hours? Sometimes it's a new application. You're not replacing something already in use, like on top of it, right? Even if you're deploying in parallel of something that's already in use, I love to deploy these during business hours, because if something goes bump, other teams like infrastructure or licensing, security or data security are available. And if we need a rush or if we need some pressure, we have management or product manager or scrum master in place to help drive and get the other team's attention that we need help. Smoke test, once you get in prod, is usually the responsibility of the dev team. This may change from client to client or culture to culture, but it's usually a combination of the QA team and the engineering team, people just making sure that key things are working. I love the engineering team because they know under the hood what features to hit to test certain pieces of the solution. QA team may just look at features and they probably know what features are the core features, but I love my engineering team because they know we need to do XYZ to make sure the Power Automate is working, or we need to do XYZ to make sure the security between the handoff in Azure AI, if you're using principal identities, all of that is working as expected. I need to purposely trigger or simulate a critical error to make sure that my logging and all this stuff, my notifications, all that is working. Engineers would know exactly what those are. And this is not a shoot from the hip smoke test. This is a well-designed, well-articulated, well-structured, intentional smoke test script or test cases that you go through. Are they the same test cases you use in QA and in unit testing? Maybe, right? Maybe. But, they're intentional tests to test certain pieces of it, and you kind of go from there. All right, and then you just go into hyper support. What does that mean exactly? Okay, we went through all this testing. We went through all this QA unit testing. We did smoke tests. And even with all of that, we're never bug free. And I know that, there's a lot of people out there that says you should be. That's why you do this. No, we do all that to minimize the amount of bugs that we have with production, to minimize the amount of blaring issues that we should have caught before our end users hit it. So there's a framework to know that we're going to run into something. How do we react to that? So there's an intake process. And again, there could be anything from, hey, SharePoint list, or no, I got my help desk already on standby. They know this new application was just released. So we got categories and workloads and ServiceNow or whatever help desk ticketing systems you use. What the end user is going to do is do the natural thing that they normally do, is create a help desk ticket, email the help desk, and identify what issue that they're having, right? Critical resolution. Usually this is for mission critical apps where certain things need to be addressed ASAP, right? Because it could be a data integrity thing, or it could be hey, this is blocking the process and this is a mission critical process. So we need you to do a hot fix or immediate fix to production ASAP. And what we do is we fix it. We still do our smoke test. We still have QA tested, and then we deploy it. Usually with all these issues, the first thing we try to do is to make sure we can replicate it. Can you replicate it in production? More importantly, can you replicate it in non-prod? In non-prod, if you can replicate it, it's easier because you can confirm the fix right before you push out to prod. The tricky ones is that it's a production-only issue. And you do analysis or whatever, you figure out what it is, come up with the fix. You can't really test it because you can't reproduce it. And it's just one of those things that as soon as you push it up, you want to validate that as soon as possible. As people start using this, everything gets reported as an issue. It could be a nice to have. It could be a real issue. It's not that critical, so let's put it on the backlog. Or this is not an issue. This is an enhancement. This is someone say, hey, it would be nice if you guys did X, Y, Z. For those with strong opinions, they may say, this is missing and it's a defect because I feel like it's important. It's important. It could be a key piece of the business process that was missed. That's how we roll with building these AI architects. A lot of these pieces you already have in place. I would say a lot of this when it comes to AI is really logging everything that you send to the AI and the results, because when they say, hey, I asked for this and I didn't get it, or it gave me this weird response. You want to be able to see that because most of the time what it is fine-tuning the prompt. The AI model is fine-tuning the prompt, getting very particular with the prompt. And it could be use cases to say, when this is asked, here are examples of how to respond to these set of questions. That's what you call model fine-tuning. And that kind of takes us down a different route because you have a fine-tuned model, then you got the standard model. So now you need to adjust your process to use the fine-tuned model. And usually there's an ID to kind of help identifying that fine-tuned model in the O3 or O1 or in the GPT itself. Very interested in your feedback, your comments. If you have any questions or need clarity, please leave that in the comment. Let's get busy building this out. We're going to walk through building this process, and I'll see you in the next video.